In this lesson of 11.4, we're going to be looking at the effects of changing dimensions. So as we look at different figures, we're going to change their dimensions. So maybe changing their height by a factor of 2, or changing their width or their diagonals. Whatever that dimension is, we're going to change it and see how it affects the perimeter and also the area. So when we look at this first example, in A, it's just going to have us double the height. And so we want to describe what happens to the perimeter and the area when this happens. So first, let's look at what it is originally. Okay, so if I want to find the perimeter of this triangle, I need to find that third side. And so to find that third side, I need to do a squared plus b squared equals c squared, my Pythagorean theorem. So I would plug that in and then solve. Once I solve for this, you would end up getting that c is 5. This is also a Pythagorean triple. So the perimeter for this would just be adding all those parts. So I do 4 plus 3 plus 5, all my sides together. And so I would end up getting that the perimeter is 12 centimeters. If we want to do area is for a triangle is 1/2 base times height. So if I want to find my area, I just plug my parts in. So 1/2 3 times 4. And so that's going to end up giving me 6 centimeters squared. So I'm going to go ahead and write these off to the side. I'm going to erase this part. And we're going to write that the original perimeter we have there is 12 centimeters. And then for area, we have 6 centimeters squared. So now we need to look at actually doubling the height. So if we double our height, instead of 4 centimeters, this is now going to turn into 8. So now we're going to find the perimeter and the area based on that. So again, we're going to start off with doing Pythagorean theorem. So we have a squared plus b squared equals c squared. So we plug in, we have 8, 3, and now we need to solve for this new c. It's no longer going to be 5. And so we need to find out what it's going to be now. So c squared again. So when I do a squared, I get 64. 3 squared, I get 9. Add those together, you end up getting 73. To get c by itself, we take the square root. And so c is the square root of 73. We can approximate that and get a decimal. And so when we do the decimal, we get about 8.54. So now if we do our perimeter, we would just add all the sides. So 8.54 plus 8 plus 3. And so when you add all that up, you're going to get that the perimeter is about 19.54 centimeters. Okay, and this is going to be our new after doubling the height. And then for area, we're still going to do 1/2 base times height. So for area, we would do 1/2 8 times 3. And so we get that the area is 12 centimeters squared. And so we want to describe how this change affected the perimeter and the area. So the perimeter, we're going to look at what the difference is. So if I look at doing my new perimeter, 19.54, and I subtract from it the original of 12, my perimeter changed by about 7.54 centimeters. So I'm going to say that the perimeter increased by 7.54 centimeters. The area, we're going to look at how it changed by a scale factor. So what I'm going to do for area is I'm actually going to do 12 divided by the original, or the new one divided by the original. And so it changed by a scale factor of 2. And so I would just say the area changed by a scale factor of 2. And so for B, you would do the same process. You would go ahead and multiply your length by 1/3, And then again, you would look at how the perimeter changes, if it increases, if it decreases, and how the area changes as well, by what scale factor. For this next example, we're actually going to change both or multiple dimensions of our shape. And then again, we're going to look at how it affects the perimeter and how it affects the area. So we're just going to do A. B, we're going to leave alone, but we're going to do A. So A, we are going to double the length and we're going to triple the width. So just like the last one that we did, first we're going to go ahead and just look at the original perimeter in the area. So we just do our original shape. For our perimeter, we would add all sides again. So we would do 6 plus 7 plus 6 plus 7, going all the way around it. And so when I add all that up, I get 26 meters. For area, I just do length times width, or base times height. So I would just have 7 times 6. And so 7 times 6 is 42. And that would be meters squared. So now we need to actually change our dimensions. Okay, so we're going to double the length and we're going to triple the width. So doubling the length, now we're going to have 14 meters as our length. And tripling our width means we're going to have 18 meters on this side. So now our new perimeter and area. So once again, perimeter, we're going to add all sides. So we would do 14 plus 18 plus 14 plus 18. And so for the perimeter, we would end up getting 64 meters. For the area, we do length times width again, or base times height. So we do 14 times 18. And so when we do that, we get 252 meters squared. So just like the last problem, we want to describe how this changes. So for perimeter, I'm going to subtract them. So I'm going to do 64, my new perimeter minus my original. When I do that, it changes positively by 38, so I would end up saying that the perimeter increases by 38 centimeters, or meters, sorry. Our area, we do it as a scale factor again. So area, I have to figure out how it changes. I'm going to look at doing the new 252 over the original. So 252 divided by 42 gives me a scale factor of 6. And so to state that, I'm going to say that the area changes by a scale factor of 6. So if you notice at the top of this example, it says that we've been changing the dimensions non-proportionally. That means we've only been changing different dimensions by different numbers. We've only changed one dimension. So like in A, how we doubled the length, but we tripled the width. We didn't change it by the same number. Now we're going to look at whenever we change them proportionally. Okay, and when we change them proportionally, it means that the resulting figure is going to be similar. Okay, so now we're going to have an original shape, and then we're going to have a similar shape, just like when we talked about similarity before in previous chapters. We talked about like dilating a figure, dilating it by a scale factor. It creates a similar figure whenever we do that. And so that's what we're going to be looking at here. And now we're just, again, going to look at the effects that it has whenever we do that to the perimeter and the area of those figures. And so this table tells us what happens, actually. Perimeter is going to change by that scale factor. Okay, all you would do is multiply the original perimeter by the scale factor, and that would be your new perimeter of the shape. Area, we're going to multiply it by the scale factor squared. Okay, whatever we're multiplying those dimensions by, we're going to square it and multiply it by the area, and that will give us our new area. Okay, and you can think about these as like the labels. Okay, for perimeter, the labels are always like meters, inches, just a unit, a plain unit. Okay, but area is always those units squared. It's centimeters squared, meters squared, inches squared. And so we're going to square those dimensions, that scale factor, in order to get our new area. Okay, so now that we've seen the property, they've already told us what happens, we're going to go ahead and just look at this example and apply that. So we want to find the perimeter and the area of this parallelogram. So first we're going to start off working just like we did those first two examples. Okay, so my perimeter here would be to add all of our sides up. Okay, so we're going to do the original on this side. So I'll do 10 plus 5 plus 10 plus 5 going all the way around. And so that gives me a perimeter of 30 meters. For area, this is just a parallelogram, so we do base times height, so 10 times 4, so it gives us 40 meters squared. So now we're going to change the dimensions, okay? We're going to double those dimensions, okay? So what we're going to do now is instead of this 10, this is now going to become 20, and instead of our 4, it's going to become 8. And so to find our new dimensions, our new shape, perimeter, and area, we're actually going to apply what they told us in the previous concepts. So when we look back here, it tells us when we change it, we're going to multiply perimeter by that scale factor, and we're going to multiply area by that scale factor squared. Okay, so if my perimeter, so the perimeter of this new and the area of the new shape, I'm going to do scale factor times the original perimeter, and I'm going to do scale factor squared times the original area. Okay, so all I'm going to do is I'm going to plug these in. Okay, so my 40 and my 30, I'm going to plug them in. My K, my scale factor, since we doubled it up here, that is what our K is. Okay, 2 is our K because we double, means that we're just multiplying by 2. So that's what I'm going to plug in for our K here. So for my new perimeter, I would do 2 times the original of 30. And so I end up getting that the new perimeter would be 60 meters. For my area, I'm going to plug in 2 for K, so it's 2 squared times my original area of 40. 2 squared gives me 4 times 40. And so when I multiply that out, I end up getting 160 meters squared. And so when we go to describe this one, okay, in this case, we already know exactly how it changed, right, because of the formulas that we have. We know that we multiply perimeter by the scale factor. In this case, that was 2, so we just doubled the perimeter. So I'm going to describe it as just saying the perimeter was doubled, okay, or you could say the perimeter increased by 30 meters, or you could say that the perimeter was multiplied by 2, okay, and then the area was multiplied by 4. It increased by a scale factor of 4. Or you also could have said it increased by 2 squared, okay, or something like that to those means. And so this is how our perimeter and our area is going to change whenever we have proportional dimension changes.